You're good to go, Scott.
Good evening, everybody. Tonight's presentation is by Henry Boyd, who's the president of Boyd Artisan Well Company. He's going to talk about well system basics, and I'm going to turn it over to Henry. Thank you for coming.
Well, good evening. Good evening. Thank you for inviting me here. So everybody's online here. So
yes.
All right, we're starting to start with it's going to be all flow testing, well maintenance, and disinfection. And also I'm going to end up doing is just reading this to you and adding a little bit to it. Why is well maintenance important? For the safety, the purity, the protection. It's the family investment is in your home and with your water, and you want to know what the water source is when you drill a well. What home inspector should look for: the flow of the well, the type of pump, type of tank, water usage requirements, preventable maintenance, filtration, and water quality. So you should always look for like big tanks in the basement. That's an indicator there's a problem. Just try her again. Click. There you go. All right, to do flow testing, in a bathroom, that's your biggest faucet. If you just want to see what kind of pressure they're going to have, what kind of quick volume they're going to have, you want to take a gallon jug and open the faucet up under cold water conditions, and it should fill a gallon jug in about 12 seconds. To determine how much water that is, you take 60 seconds in a minute, divide it by 12, the 12 seconds it took to fill the jug, you got 5 gallons a minute. If you're going to check the faucet in the kitchen, you're going to take once again that gallon jug, you turn it on full, let it run for a minute, and you should 40 seconds on the average, you should fill a gallon jug. Once again, you take 60 seconds, divide it by 40, you come out 1.5, which is 1.5 gallons a minute. So that's about the average of all the faucets should be. Click. Calculation for volume of a reservoir of a 6-inch well. The 6-inch well holds 1.5 gallons of water per foot. That's a 6-inch well is an average well. Static water level is the level of the well fills to when not in use. The water is stopped. It's static. 6-inch well, 150 feet deep with a 50-foot static water level, holds how much water? 150 feet minus 50 feet equals 100 feet of water. 100 feet of water times 1.5 gallons. 100 foot of water is 150 gallons of water. As long as there's a good flow coming in the well, that's plenty of reservoir. But if you don't have much flow coming in the well, then it's a problem. A 6-inch well, 60 feet deep, with a 10-foot static water level holds how much water? 60 feet minus 10 feet is 50 feet of water. 50 feet of water times 1.5, you have 75 gallons of water. Once again, if there's plenty of water coming in the well, 5 or 10 gallons a minute coming in, it's fine. A 6-inch well can hold up to 900 gallons if the well's filled to the top. And that gives you a great reservoir. So in the morning when you wake up, you have plenty of water. Is the supply dependable? Volume of the well will determine the length of the time the well needs to run to determine whether the supply is dependable. You should, so for 5 gallons a minute times 60 minutes is equal 300 gallons an hour. You figure in normal houses, you figure about 200 gallons per bedroom. So if it's a 3-bedroom house, you need 600 gallons a day. So 5 gallons a minute is 300 gallons an hour. You might want to run a hose for 2 hours at least. I always recommend to people when you're just checking out somebody's place to put the hose on, and I always tell people let it run for 4 hours. Quite often people call me and ask me to come and do an inspection. Really, the most important thing is the volume of water in the well. The equipment in the house is all replaceable. It will have to be replaced after certain period of time. We can't tell how old the pump is or how long it's going to last. Some pumps only last a month. Some pumps last 25 years. So you want to just throw the hose out and make sure they got a good well. Especially this year, we had a drought, and we had an awful lot of people buying houses without checking the wells, maybe not even having a inspector out around, bought the houses, and then they call you up and say, hey, there's something wrong here. So let's try again. Types of pumps. We have submersible pumps for all wells. We have jet pumps for wells 0 to 120 feet. A jet pump is in the basement. The submersible pump's in the well. Jet pump's in the basement. A jet pump has 2 pipes going down the well, a pressure line and a suction line. And the third type is a suction pump, which only has 1 pipe going out to the well. It's used in shallow wells for wells 0 to 25 feet. A vacuum pump will not lift water more than 25 feet. They're all centrifuge pumps. The other one is a piston reciprocating pump. The little pistons go back and forth, and it usually has a belt on it. And really, you don't see those very much unless it's a 40-year-old, 60-year-old house. They can still have them. And of course, you got good old-fashioned hand pumps. This is a typical submersible installation. You see, you have the pump in the well. The line comes up to a pitless adapter. The line goes into the house, and you have your tank inside, and you have your control box on the wall with a switch. Your pressure switch is down at the bottom of the tank with a safety valve. Click. So when you're checking out a house, things to determine the depth and flow, look at the control box. If it has a 3-wire pump, it'll have a control box. It looks like this. This is a Franklin control box. Franklin was the main pump company for a long time, main motor company. They have split up.
Oh, hold on, Henry, you there? I think he froze. Hold on. Give him a second.
Start.
Oh. Henry, you're still frozen.
I see.
He's going to have to log back on.
Okay.
There we go. Oh, you there?
Yeah.
I'm here.
Oh, okay. So can you start over again with the control box for 3-wire?
Sure. Yeah. Things look to determine the depth and flow of a well, which helps us do the depth and flow. Control box, the picture of it, a Franklin control box. It has this is a 3-wire pump. There are 2-wire pumps, and you can't tell anything except by looking at the size of the wire. The control box across the bottom of it will tell you the horsepower. If it says a 3rd horse on there, it's the last 25 years they haven't made 3rd horsepower motors. So it's going to start at a 1/2 to a 1 horse with this shaped box. And that means you're going to at least 5 gallons a minute is the minimum because that pump is going to be capable of pumping, and it could pump a lot more. 3rd to a 1/2 horsepower are 100 feet to 250 feet in depth. 3/4 down to 450, and a 1 horse can pump down to 600 feet. Control box for a 3-wire pump submersible will have a heavy duty with manual overload reset on the bottom. So little red button on the bottom of that box. And that just kicks off now and then if the pump runs dry. It'll shut it off and let it relax for a while. Get down and push the button hard, and quite often it'll take off. Sometimes a lightning storm will kick them off. These boxes range from 1.5 horses to 3 horses at this size right here for high volume pumping or well depths from 600 to 900 feet. You can also pump a big flow of water with these. Factors determine flow and depth. You can high yields. You might have the high yields. You can have 1.25 inch pipe into the tank from the well. Deeper wells only have a 1-inch pipe and with a heavy gauge electric wire. Determining low yield wells. If you see a little box on there, it looks like a pump tech or a pump miser. When I first made this, the old pump tech was the only one out there. Now they have a pump miser they put on, which does the same job. So the pump tech continuously monitors the pump's running amperage load and automatically shuts the motor off when the pump amperage drops due to low water intake. So a pump is, when it's running, it's always drawing about the same amps. A half horsepower pump draws about 6.5 to 7 amps all the time when it's pumping. But when the water level goes down, it's not pumping anymore. So the pump starts to freewheel and the amperage drops down, and this little computer just picks that up and shuts it off. They're great things to have on. If you see a pump tech on a well, beware. Make sure they do a flow test on the well. A low cutoff pressure switch shuts the pump off when the pressure is lower than 15 pounds. Requires a manual reset until pressure is up to 20. That's a regular square D pressure switch, but there's a little lever sticking out of it. If you see that little lever sticking out, once again, there could be a problem with that. So if it shuts off, you just have to turn that to hear the pump click back on again. And you have to hold it until it gets up to 20 pounds. And then it takes off by itself again. But once again, people use those to try to save their pump. Wire sizes to determine depth. If you have to look at the wire size. Number one, you got to look at the circuit breaker, see if it's 110 or 220 pump. 110 pumps are only half horsepower, and they require, if they're down over 150 feet, you have to have a number 10 wire going down to them. So so you know that pumps down as far as it can go. If you have a number 10 wire, you know it's probably a 1 horsepower pump. That could be down 600 feet. If it's a number 8 wire, this could be much deeper, or a long distance from the house to the well. We measure the wire from the control box. No, I'm sorry, from the control panel at the house, the circuit breaker coming in the house, to the pump. So if you have a 200-foot ditch and the house is 100 feet long, you're already losing 300 feet of wire. So sometimes you got to run a heavier wire. But if it has a real heavy wire, look to see if it's an 1 1/4 line coming in or 1 inch line coming in. That tells us that's a deep well.
Henry, may I ask what's your preference when it comes to the wires? I know sometimes they have the regular loose wires, they're twisted wires. Sometimes they have the double cased wires. They have the flat cased wires, which they sell them on the idea that they get less friction against the casing. That way they're tighter to the water line. Any opinion on that?
Oh, definitely. We only use the double jacketed wire. It's a little skinnier, but a lot of pumps, depending on who the installer is, and especially in Connecticut, people use poly pipe, and it's like hanging your pump on an elastic band. And every time the pump starts, the old style pumps start, they kick. And we put center guides on them, torque arresters. It keeps them in the center and tries to stop that kick. But with a double jacketed wire, once again, it does tape in tighter to the wire, to the pipe. Of course, I use the word tape. We're really shouldn't use tape because it's got toluene in it. And the toluene, I was in the Westport Health Department about 10 years ago, and they thought the whole town was having toluene problems. And I listened to this conversation, and I was butted in, like I always do, and told them, if it's a new installation with tape, you're going to get toluene for about the first 3 months, because it's where the tape goes over the wire, and there's a little space where it gets over to the pipe. It goes around the pipe. That little bit of toluene that's on that tape will screw up a water test. When we do test pumps or anything, testing a new well, we have to use wire ties, or we have to hold the wire on with something else besides tape. This is a chart that just tells you, you probably can't read it because I can't hardly read it. It just tells you the different horsepowers and the different depths that a pump can pump. I mean, if you look at some of those, the first one is a 10 gallon a minute pump curve, and that goes up down to 1,000 feet. But that's a mighty big pump to pump 1,000 feet. But at the top of the curve, it's not making anything, and your average is kind of right in the middle of that curve is where you want to set a pump. Click. Yep. Jet pumps and suction pumps installation. The first one on the left is a suction pump. It's only one pipe coming in. Usually it's an inch and a quarter. If you see that, you know it's a really, really good well or a really good shallow well. You can have 1,000-foot well, but the water will come up and overflow over the top of the well. You can use a shallow well pump on that. And they do last a long time. As long as you just have like a captive air tank on them, they will last and last and last. The jet pumps on the right, it's two pipes. There's an inch and a quarter pipe, which is a vacuum line, and there's a pressure line. And when the pump comes on, it pushes about 27 pounds pressure down into a venturi down at the bottom of the well by the foot valve. And it makes a secondary vacuum in the bottom. And those pumps are good for about 120 feet. Years ago, they used to have a multi-stage pump that would go 180 feet. But that's like a horse and a half or 2 horsepower pump. But 50 years ago, that's kind of all we had. But the jet pump is, once again, long lasting. And of course, the problem is you have to have a pitless adapter with them today. You can't run a sanitary seal. That's the black disc around there. What's marked sanitary seal. It's an oxymoron that it's sanitary because the gasket gives up after a while. Or on a submersible, well, we'll see about the submersible in a minute.
Henry, may I ask,
Yeah.
over time I've been told that with the 2-line jet pumps, you move about 3 gallons of water for every gallon you put in the tank. Is that true?
Yeah. For every 5 gallons of, you're pumping about 5-6 gallons a minute with it. So about 50% of the water that you're getting in the tank, 50% of that has been pumped back down in the well. So if you're getting 5 gallons a minute in there, the pump's been pumping 10 gallons a minute. It goes down, it pushes it down and blows it up through that venturi, the secondary vacuum. So when the water comes up, it's divided out and half of it goes back down the well again. That's the inefficiency of those pumps because you're pumping 10 gallons a minute and only getting 5 gallons a minute. So where a submersible pump runs 30 to 50% less electricity because it's just pushing it one way. So tanks, there's 3 types of tanks. A captive air tank, that's the blue tanks you see in a basement, or it can be a fiberglass tank. They have a diaphragm across them, the blue tanks, and which separates the air from the water. You'll always have to have an air cushion. If that bladder breaks in there, the air will come out and the tank will get waterlogged. And then the pump will start going on and off and on and off in short cycle and burn out the pump. So people always got to listen for that switch clicking on and off and on and off. The pressure is going to be gush out and stop, gush out and almost stop. So people will realize there's a problem. The plastic tanks are captive air tanks. They're fiberglass. They have a bag inside of them. And they don't last quite as long, but they still keep pumps from burning out for quite a while. Yeah.
Yeah. A couple things. Could you just talk a little bit about, sometimes we go in there. Can you just tell us a way that we can determine that tank is failed? What are some of the things that we may be able to tell?
The easiest thing is you tap the tank with your knuckles, and the top of the tank should sound empty because it's full of water. And the bottom third of the tank, that's where it sweats around the bottom. You see they get rusty around the bottom more. And you tap that, and if there's solid, the tank is fine. If you can also watch for where there's sweat marks on them. That's the only way you can tell. You can drain the system out completely, shut the pump off, drain all the water out of it, and then take a pressure gauge and put it on the top of on the air side of the tank. And it should have anywhere between 25 to 40 pounds pressure, depending on the pressure you're working with whatever the pressure switch is set at.
What are typical pressures set at?
Today, 20 years ago, it was 30 to 50 pounds on the pressure switch. Today, in the last 20 years, we go to 40 to 60. So in Connecticut, you guys build all these tall houses, so you need more pressure for upstairs. So if it's a 40-60 pressure system, if the pump starts at 40, you always want to have the tank pressure 2 to 3 pounds less than the start pressure, because it gives the tank a couple of seconds, gives the switch a couple of seconds to come on before you run out of water. The pros and cons to these tanks is they make a pump last a lot longer. The problem is if the power goes out, these tanks don't hold a lot of water. They call it an 80-gallon tank. It's the same size as a 40-gallon tank, has the same cycle as an 80-gallon tank. But a 40-gallon tank, the cycle capacity is about 9 gallons of water, whereas which is equivalent to a galvanized 80-gallon tank. So let me just do it. A galvanized tank needs air charging all the time. Or the third type of storage is an open storage tank, like the white tanks you find in a basement, where the pump fills that tank, and you have another booster pump that pushes the water out of there. Today we have constant pressure systems, which are very small captive air tanks. But let me go back to galvanized tanks, and they have to be charged with air all the time. So those are the ones. Well drillers, as far as well drillers are concerned, the captive air tanks have spoiled the industry. They make the pumps last longer. And with the old galvanized tanks, maybe twice a year, we'd have to take a little compressor and put air in them. And that gave you a nice service call on a Saturday morning when it was raining. Galvanized tanks also have a recharge system. To get the air in them, we put a hole in the pipe, a little 1/8-inch hole, 20 feet down in the well. And there's a check valve coming into the tank with a little snifter valve, little tire valve on the pump side of the check valve. And when the pump comes on, it fills the tank up. When it shuts off, the little hole drains the water out of that line. It also keeps it from freezing. Air goes in the little snifter valve. When the pump comes on, the air is pushed into the tank. It's a great system for charging tanks. I have that in my own house. And then after I get too much air in them, you have to put an air control on it. We'll show you an air control in a minute. The open storage tanks, they just have a couple of floats in them that turns them on and off, turns the pump on and off. These new constant pressure systems, they use very small tanks. I don't believe in these real small tanks. I always use a 203 tank, which is 4 feet tall and 14 inches around. It just gives the pump a little bit of time to go on and off. But with the constant pressure, when it only goes down about 5 pounds of pressure and the pump comes on, and then it maintains that pressure all the time. The pump comes up to that speed, and if you have a second faucet that opens up, the pump speeds up. They're great for irrigation systems. You have 2 or 3 zones that open up and close. The constant pressure systems are great for that. Really, you see everybody's putting them in now. People really like the extra pressure instead of going from 40 to 60 to 40 to 60. It's always just a few pounds, and the pump is right there. So if you see a small tank on the system, real small tank, the size of a basketball, don't get too excited because the factory recommends that. So let's try again. Well, this is a regular pressure system on the left. Your pump comes on, it pumps the water into your tank. Pressure switch shuts it off. On the right, it's an open system where the pump comes on, pumps the water into your open storage tank. Floats are in the top of it. They shut the pump on to control the pump. And then the water to the service there on the bottom, it goes to a booster pump of some kind. They have these DAB pumps today, which don't require a tank or anything. They just maintain once again, it's a constant pressure pump. And they're pretty good in a house. But that makes a really expensive system. But municipal systems are, great big water tanks, 1,000-gallon tanks, use this system, but that's you have a water tower to make the pressure. Click. Safety valves, always should have a safety valve. That's what's on the left. Usually they're set around 70 pounds pressure. So if people set them up too high, set the pressure switch up too high, they start to blow off and flood the basement. On the right is what they call a tank T, which is a standard fitting on the bottom of a captive air tank. You have your pressure switch, and if it's very easy to change the setting on a pressure switch. So Joe homeowner gets in there, the where that little nut is on the top of it. If you take the cap off, that screw that's holding that, if you turn that screw down, there's a little plastic nut in there. For every one turn that you turn that down, tighten it, the pressure goes up 2 pounds. So if it's a 50-pound system, it's easy to make it a 60-pound system, 65-pound system, but don't go over 65 pounds if you're playing with it. And obviously the fittings underneath it, there's a tank T. The pipe that goes out the back, you can't see it, goes into the tank. And you have your safety valve and a boiler drain and your pressure gauge. Pressure gauges usually last about 2 years. And so you really can't depend on them.
Henry, could you tell us what the proper sequence is for setting cut in, cut out? I know you kind of back into one, maybe back out of the other. There's a certain sequence.
No, that you touch that one screw. Do not touch. Don't screw with the screw. Any other screws. There's another setting inside there, but it's set at a differential of 20 pounds. And when you turn the top screw down, once they get 1 pound, one turn for 2 pounds, it goes up. It goes up, and the bottom pressure goes up with it. It maintains that same ratio of 20 pounds between 30 to 50 to 40 to 60. Don't touch the other one. If you do, you're going to buy him a new pressure switch. It's not worth the time screwing around with it, trying to get it worked right, because it just, believe me, you're going to buy. Don't touch them if you're going to help it.
So it's not like the old. It's not like the old switches. Today you just do that one screw and it automatically adjusts the entire range up or down accordingly.
It's not even. They've been like that for 40 years at least. So if this is a typical galvanized tank, if you look at the little gauge on the side of it, you'll see that that the fitting that's holding it is a tank, is a high pressure air control. There's a float inside there, like a toilet float, and when the water level gets too low in the tank, the float drops down, lets the excess air out if your air charging system's working properly. Now that tank that you're looking at, it kind of looks like it's almost time to. Looks like the recharge system isn't working, and because the top of the tank is kind of dry and the lower section is kind of wet looking, so it's time to put some air in that tank. The way these tanks work, when they're installed, they're totally empty, full of air at 0 pounds pressure. When the water starts to go in them, as the water rises in them, you're compressing the air in the top of the tank. And the reason you have this great big tank and you still don't have a big cycle capacity, because this air is in there, and as you're filling it up, when it's up to about almost half full, you're up to 30 pounds pressure. Then you continue. Now that's a start point for a pump. So now when you continue up about another 15% of the tank, and now you're up to 50 pounds pressure, and the pump shuts off. So you're only using about 15% of an 80-gallon tank. I think that's a 120-gallon tank you're looking at. So you only use about 15% of that tank between the on and the off. The big advantage is if the power goes out, you still have a lot of dead water in the bottom of that tank, and it's good. You'll have a 120-gallon tank. You'll have 40 gallons of water in the bottom of it at less pressure, but you can still flush a toilet with it. That's the big advantage of the old galvanized tanks. As I said, you can see the mold, where the mold grows on that tank. That's the water level and the coldness of the tank. Obviously it's in a crawl space where there's no ventilation, and yet you can see how the pressure switch and everything is all hooked up in there, and with the tank T. But that's a captive air tank. That one it's working right. If it looks like that, it might be nasty looking. I'd recommend you spray with a little Clorox before somebody buys the house. But it's nothing wrong with that tank.
What are your thoughts on the insulation wraps or bubble wraps they're putting on for condensation? Good or bad?
Oh, that's good. That's good. Helps keep some of the water off and hides the mold if there's any mold under there. I've never taken one off, seen mold, so it should work good.
Henry, what's the average life expectancy of those tanks?
That tank is warranted for 5 years. I'll just give you another one. I've never gone through many of them, for warranty purposes. Usually get at least 15 years out of them. I've seen them 20, 25 years.
How about galvanized?
The one in my house is 40 years old. The little problem with galvanized tanks are, if the bottom rots out of it, it ends up in your living room or your bedroom two floors up. It takes off like a rocket. If it got, it's just like if you knock the valve off at an oxygen tank, it takes off like a rocket. Well, the tanks do that too. There was somebody had one down in Yonkers. They had a 5,000 gallon tank outside the bus garage, and there was enough water went through it all the time where it never froze. And one weekend, apparently they weren't washing the buses. The bottom of the tank froze and broke off, and it went shooting in the air. They said you could hardly see it going up or how high it went. They came down and squashed the car. So really, after 25 years or so, you should change the tanks, the galvanized tank. And you should always just change to a captive air tank.
So they're not still making and installing galvanized tanks, correct?
Well, once again, with that bleed back system, if you have a line that's only buried down a foot, you end up putting a bleed back system in it, and then you don't have problems with the freezing. And the problem with that is you set that up like that, and 20 years later, the plumber comes along and says, "Oh, I'll sell you a captive air tank." Now they have trouble with the lines freezing coming into the tank. In theory, you're supposed to bury the pipes, but not everybody does. So this is a captive air tank. When it's the one on the left, when it's no water in it, so the pump comes on, the water starts pushing on the diaphragm, and then the diaphragm stretches up, as you see on the diagram next to it. And so the dark is always the water in there. So this is why I say when you use all the water out of it, you're right down to the pump cut-in point. That's why you want to leave a few pounds of pressure less in the tank so that the pump starts before it completely flattens. And the galvanized tank.
I'm sorry to interrupt you. What is a up the pressure? I know there's probably several factors that influence. What is, 2 minutes, 3 minutes, 5 minutes?
Depends on the size of the tank. A 203 tank is, like I say, it's 14 inches by 4 feet, holds 9 gallons of water. So if you have a 5 gallon a minute pump, it should take 2 minutes. If you got a 10 gallon a minute pump, we pump it up in a minute.
Is there anything if it takes longer than that? Is there a problem?
Oh, well, that means the water level might be way down in the well. So if they've been out watering the lawn or something, and there's not a lot of water in the well, it could take longer. Maybe the pump's down to 3 gallons a minute. It takes 3 minutes to pump it up. So any less than that, people will notice it after a while that they're
flowing. And at what point on a short cycle, anything less than a minute, less than 30 or 20 seconds, at what point do you not like the short cycle because it's
30 seconds. 30 seconds, 25, 30 seconds.
At that point, you're concerned.
Yeah, and actually, when it gets really bad, the switch will just keep going click, 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 on, off, on, off. That's what's really bad for a pump motor. So on the galvanized tank next to it, the galvanized tank, you can see where the tank is about half full of water, and it only pumps up to where it says drawdown. You're going to pump up to there, and the pump shuts off. So that's the cycle of the tank, the drawdown. And even though the whole tank is full of water, but it's the water from the on the left-hand side, from there on down, it's less than 30 pounds pressure. But it's, if the power's only going to go out for half an hour, it's great. That's the only thing good I can say about them. Click, 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 click. Okay, filtration. Lots of filtration equipment could mean problems with water quality. Place in Connecticut, man, you guys got lots of iron in places. Water softener use salt to recharge and discharge chlorides into the groundwater, which can pollute the surrounding wells. I am an anti-salt person, an anti-water softener person because of that. The road salt is the worst thing for wells. And when you get salt in your well, salt water is denser than fresh water. And all water comes from rain. So when it rains, the water goes down and fills up the aquifers in the ground. And when you get salt in the ground, the rain takes the salt down into your water. And there's no natural filtration for salt. None. The water in the ocean evaporates. Evaporation is really the only way. Or if you boil a tea kettle, the salt will stay in the tea kettle. But to have salty water, you end up with a big filtration system, which is about $12,000 to $20,000 to call it a reverse osmosis filter. And for every 1 gallon of clean water it filters, you use about 3 to 5 gallons of water to discharge out. So once again, they'll have a big white storage tank in the basement. They dump into that. They filter about 1 gallon a minute roughly, and so you have this storage tank you have to fill up to have normal pressure in the house. But it's a shame that we use so much salt on the roads, and water softeners do the same thing. People use a couple 100 pounds of salt every couple months, and that's just no natural filtration, and it screws up a lot of wells. We get a lot of calls from people about salt in their wells. And once again, up on the top, lots of filtration. You got to be really aware. You can't tell what it's filtering. You can tell if it's a water softener because it'll have a salt tank next to it. Other types of filtration could be just for hardness. They could be for pH problems, low pH, high pH, but those tanks are not marked. And the tanks are all the same, except they just change the pigment inside to satisfy whatever they need.
So are we seeing more problems with all this salt because they went from the salt mixture to just plain salt now? Are we seeing a lot of issues?
A lot of issues. Yes. A lot of issues. And it's just really not, sometimes you got enough property, we go to the back of your property away from the road and drill you another well, or you put it in this real filtration, expensive filtration system. And basically the inside of reverse osmosis system looks like a big roll of saran wrap. It's a plastic liner with layers, and the layers are so fine that even the dissolved salt in the water can't pass through it. Pressurize it through this membrane, and then at the same time you have water running across the membrane, washing the junk off the membrane. So the salt and it purifies everything. When you get all done with that, then you have such pure water, it's not really that good to drink. A lot of people end up putting minerals back in the water by having a tank full of limestone, and you run the water through the limestone. It makes the water a little harder, which you're putting. Hardness is nothing but limestone and dissolved limestone, and they dissolve the limestone sometimes just to give it some flavor and give it. Make it so it's better for you. If you drink too much distilled water, you will die. If that's all you drank, because the water sucks, the clean water will suck the minerals out of your body and out of your cells, and you will die after a while.
So Henry, during our inspections, we will come into a home, we'll see a water softener that's discharging into a septic tank, and they're not allowed to do that anymore.
No.
So the septic guy will tell you, or certain towns have regulations. That salty discharge can just come out of a pipe and flow onto the ground. It can go into a corrugated pipe into the ground or into a dry well. So what you're telling me is that they're taking that salty discharge, even if it's going into a dry well, it's going to eventually seep into the ground, and they're contaminating their own well with salt.
Correct. Yeah,
That's great.
And of course, but putting the salt into your septic, if you have the septic's all full of concrete. It's a concrete tank normally, and concrete junction boxes in the fields. So the salt eventually eats them up, and people end up changing the tanks. The code is today you're supposed to dig a dry well for it, but it's still salt going into the ground. They're just trying to protect the septic tanks. That's why they're doing that. But that makes it expensive putting in a water softener.
Could I get one last question in on that?
Yeah.
So if the water's got just typical hardness and people, feel like that it's going to corrode their sinks and so on and so forth, is there something that can be done to just lower the hardness? Maybe not quite as much as a softener would, but is there any kind of filtration that can be used, in place of a water softener?
There supposedly there's a system where they run electricity through the water, and they change. I couldn't tell you which way. The ions are positive ions the negative ions coming out of the well, and they treat them and they change the negative to a positive ion. You'll still have the hardness in there, so you still have the flavor of the hard water. I mean, hard water tastes much better than soft water, at least to me. And they change the positive and negative of it, and so the hardness won't stick to the inside of a furnace. Anytime you heat anything, that's when the hardness really sticks to things. So the water heater or a coil in a furnace plugs up frequently with really hard water. So they just keep that from sticking in. Some people say they're great. Some people say they're not great. So I can't comment on it because I really don't know if they work or not. That's the only thing that you can do. So
Thank you.
We do have a question about sediment. Someone has asked, I have so much sediment in my water and I have a house filter. All my faucets and showers constantly get low pressure because of debris.
Well, that's because the filter's plugging up, not because the faucets are going bad. But if your filter's working properly, it's going to pick all that junk up. And there's different types of filters. I mean, you can get big backwash filters, look like a water softener. They're probably about $2,000, but it's a backwash. It's a sand filter. That's all it is. And it does an automatic backwash. If people get tired of changing the little filters, and the little filters, you can get doubles, and you can get fatter filters, bigger ones that are like 4 inches around the filter itself. Typical house filter is 2.5 inches around. So you can get double filters like that. You don't have to change them as much. And if you're changing those things, man, don't ever take a filter apart for somebody doing them a favor, because it's just so hard to get them to stop leaking. It's unbelievable, especially when it's been an older one, because the gaskets dry out in them. I mean, I've seen where we did people a favor, we'll change it for them, and the first thing you know, we're giving them a new housing for the filter. And some of the filters that we use have a big nut on them, so you don't have to turn the housing itself to get the filter out. There's a big nut holding the housing up. You spin the nut off, then just wiggle at a time and it comes off. And when you go to put it back on, instead of trying to turn the filter and line it all up, just push the housing out, then just spin this nut up and tightens it up. If you're ever recommending anything to people, that's a good filter to recommend. Okay. Coliform bacteria. Water quality tests. Coliform bacteria is a non-pathogenic. Coliform is non-pathogenic. I mean, it won't hurt you, but it suggests favorable conditions for the pathogenic organisms like E. coli. E. coli will make you sick. Coliform will not really make you sick. It's not really good for babies or people with immune problems, but half the time you get a water test that comes back with coliform in it. It's really hard to get a test without coliform, especially if you're taking it outside. You should always take it in the kitchen sink. But I'm sure all of you do coliform bacteria. So when you do a coliform bacteria, you run the kitchen sink, wash your hands, roll your sleeves up, wash your hands. When you let it run a few minutes, I mean, they say put a match underneath the faucet. I never do that. I end up burning the plastic filters out of the faucet. Then you got to buy them a new faucet filter. We just let it run good, cold water. Make sure the window is closed in front of the thing, so there's no breezes or anything, and quickly just uncap the bottle, stick the bottle under there, and keep the other cap in your hand and cap it quickly. Then keep it cool until you get it to a lab. Nitrates and nitrites. Did anybody ever tell you about nitrates and nitrites when your wives were having babies? Nitrites will choke off a fetus. People that have trouble having babies can have their water tested, and if there's a lot of nitrates in it, it'll choke off a fetus. And nitrates can turn into nitrites in a woman, which is bad for the baby. And nitrites are the only two chemicals that you can combine to make a total of 10 parts per million. There's nothing else that they can combine, but 10 is the maximum. It could be 2 nitrates and 6 nitrites, then it's okay. But if it goes to 10, you got a problem. And if it is that, you always warn people: drink bottled water that they're a little bit pregnant. It'll also make blue babies. If out west they have a lot bigger problems with nitrates. We have the farm country, and they're always dumping fertilizer on the corn or something. So, but always remember, if somebody's a little bit pregnant, tell them no drinking water without testing it. Anything else that is a local concern is something you always got to look at. I mean, iron, manganese, whatever. Examples: iron, manganese, hardness, sulfides, or sulfur, and arsenic. Where I live, the next mountain over from me, there was an arsenic mine, and that's done a few people in. And it wasn't that bad, but somebody bought a house right in front of the arsenic mine. You could see the arsenic mine. You could throw a rock to it, and they drilled a new well. Fortunately, I didn't do it, and they all got really, really sick. The state of New York bought the 3 or 4 houses right in front of it, tore them down, and made it so that no again. So current drinking water maximum contaminant levels MCL can be found at whatever that is, the government. Yeah. So.
Excuse me, Henry, when we show up at a house and running the water and you get a rotten egg smell, that sulfur smell, are we talking sulfur, manganese, iron? What's causing that in the water? And it's usually more pronounced in the hot water side.
Sulfur. It's quite often sulfur, or it's bacteria. If you have a little septic leaking into your well, it'll smell the same way. But that comes back in your bacteria test. And sulfur, you get sulfur bacteria in a well. We can go in and plunge a well and clean a well, called surging a well, where we got a rig like a big toilet plunger. It's what they call a cable tow rig. It's what we used to drill with years ago. It's a 1-ton weight. We used to hang it on a cable. We used to pick it up 2 feet and drop it. Pick it up 2 feet and drop it about 55 times a minute. That's the way we used to drill wells back in the 50s and 60s. There's still a few people that do it. It's a great way to drill a well. It's just so slow. But we take that rig in, we take the drill bit off the bottom of the weight and load it up, and put these big rubber washers on the bottom of that drill weight, and load a well with a strong solution of chlorine. And we plunge the well for a couple of days. We take the chlorine and we lower the pH of the water. If you at 5.5, chlorine is a total biocidal. It'll kill everything. With higher pH in the water, this is why you get bad water quality tests sometimes. If you got really, really high pH in the water, if water has say it's a pH of 8, when you put chlorine in there, it only kills about 12%. It only has about 12% killing capacity. At pH of 10, you only have about 2% killing capacity. So if you have trouble with bacteria in a well, you want to use pH minus, and you lower the pH of the water in the well, and then you put your chlorine in, and then that's a double shock. And then you run the water from the outside faucet into the well and run that for a couple hours. So you're circulating the water around, down the well, through the pumping system, through the tank, through the hose, and back down the well. So you thoroughly disinfect that well. And quite often that'll help the sulfur, because you get sulfur bacteria in it. And this plunging process that we do, it's like $5,000, but quite often it'll take care of that bacteria. It's something that builds up in a well, and we also do the same thing for iron bacteria. And dirty, a well gets really dirty sometimes, and we go in and plunge it for a couple days, and we'll clean a well up. Sometimes even they start to dry up. We have a deeper well that starts to slow down. We're going to plunge it, because the iron bacteria, the sulfur bacteria, or the hardness will plug up the cracks in the rock. And it's just like a wells get almost like cholesterol in the water. Just like when you get through my age, you're going to really find out what cholesterol is. Cholesterol goes into your body and things don't work like they used to. Well, you get all these bacteria and minerals in the water. It's just like giving your well a dose of cholesterol. And we go in and clean that out. We're like a well driller with Lipitor for your well. So, well maintenance.
We got about 10 more minutes, Henry, so let's.
Okay. Well maintenance. Annual disinfection of the wells. The homeowner can do it. You should have a licensed driller, or one of you people can do it. There's no regulations in Connecticut about who can disinfect the well. A virtual inspection is always good. You always want to put on a vermin-proof cap. Just these little tin plates that go on the top, or aluminum plates with 3 screws. They're not very. They're full of bugs. I'll show you in a minute. Always inspect the casings today. The casings rot out right at grade level. You can put your finger through some of the casings on a 30 or 40-year-old well. And of course, then you have to do a camera inspection. Click. Oh, that's a frog. He's a very unhappy frog. He has only one eye, but he likes good water quality. Click. Problems with well pits. Well pits are a lot of them will just rust up. I'll show you in a second. They have poor ventilation. If the vent is in the well, when the pump comes on, the water goes down, air goes in your well. The air in a pit is full of bacteria, mold, mildew, and that sucks that into the water, and that affects your water. You're going to have bugs in your well pits, and surface water and contaminants can get in through what they call a sanitary seal. What is inside the well pit? That click, yeah. That's its typical tile. It's all rusted through. Water gets into there, or surface water looks like it comes up in the bottom. You see what's really red? That really red, it comes up to a certain point. And then if you look, there's a white pipe sticking up there. That white pipe is the vent for the well. And the water gets up to that high, and the water cascades into the well through the vent. And if you look, there's bugs in there, and there's all kinds of nasty little things in there, cobwebs, whatever. Click. That's just like where it's rusted through, and you can see the spiders in there. That's just nasty inside that well pit. Click. That's more of the pit where it's rusted through and surface water is getting in. That surface water gets in, and it gets right into the well. Click. And it's just bugs that were inside there. When they float around in the water and they go in the well. This is that vent pipe. If you look inside of it, you can see the color, the rust inside the pipe where the surface water has been going in the well. Click. This is what they call a sanitary seal. The problem with the sanitary seal with a submersible pump It's a rubber gasket between two metal plates, or today they make them out of plastic. But when you tighten up the bolts, there's 4 bolts in them. They tighten up the bolts, squeezes the rubber out, and around the 1-inch pipe coming down the well, it's perfect. But around the wire, the wires is 3 separate wires, and the water can get down in between the wires, even when that rubber seal is tightened up. So that's contaminants get into your well that way. Click.
Excuse me, Henry, when we see the breather in the well pit like that, sometimes it's just they didn't want to bother running it to the house, into the basement. But other times, my concern is that maybe they have a seasonal artesian type well where the static water level is higher than the wellhead, and they don't want it pouring into the basement. So they put it into the well pit. But then that's a way for your well pit to flood, and then when it drops, bring contaminants back down into the well. So when we see it in the well pit, do you think they have a seasonal artesian event, or do you think they're just being lazy?
Yeah, just the cost. Cost that little piece of plastic pipe is nothing. If you run it up, you can run it over across the ground up a side of a tree or something, a post, in case it does overflow. But yeah, you should. But that gives you fresh air too. But you always want the fresh air. And really, if you see that, the first thing you say is, have your well casing extended to surface and get rid of the pit. In Connecticut, you're supposed to. They want you to get rid of those pits all the time, every time. So it's not mandatory; it's recommended. And the cap here on the left-hand side is kind of a loose cap. It's a cast iron. Years ago, that was the premium cap, but they're still loose. Keep going. We'll show you. Click. This is a flat cap. You see it's broken. Lawnmower hit it or something. But this is the type of cap that's really bad. Click again. If you look inside that cap, there's cobwebs, there's bugs, there's all kinds of nasty things. I mean, it's like a hotel in there for bugs. It's cool in the summer. It's warm in the winter. But, when all those bugs, they get earwigs in there and these little black spiders, and the bugs poop, I imagine. And so it goes right into your well. And they die. When they die, they fall in your water. Well disinfection. Bacteria in wells. Introduced during the drilling process. Not too much. During the maintenance and the pump installation. People have this problem of dragging the pipes on the ground, especially on a redo. You have old pipes, you're pulling them out on the ground, laying them on the ground, and as you're putting them back in, it's like you're handling the pipes, putting bacteria on the pipes, and then it's like, oh, these people have a dog. And so they wipe off the pipe a little bit and wash their hands, but now you got still putting bacteria in a well. And older wells develop slime and iron bacteria. The slime is polysaccharide slime, and that's what we do with the cable tow rig, the surging, cleans that all out. Product used to disinfect wells: calcium hypochlorite, pelleted or granular chlorine, and sodium hypochlorite was liquid chlorine or bleach. Bleach has a problem. Bleach loses 25% of its chlorine every month. It sits on a shelf. So if you go down to the deli to disinfect the well and you get a gallon of bleach, it just starts out at 5.5%. And if it's been there for 4 months, there's hardly any chlorine left in it. This is why we try to use HTH pool shock, which is like 55% chlorine, and it doesn't dissipate out so fast as the liquid chlorine. So liquid chlorine just lose it quickly.
Henry, do you have a preference between the pelleted for deeper wells versus the granular for maybe somewhat more shallow wells? Or
well, like I said, if you have if you use pool pellets, you throw them in. If they don't dissolve when they get to the bottom of the well, they'll just sit in the bottom of the well. They need a little current, a little flow of water to dissolve. That's why you put the pellets in a box in a pool, and as the water goes by it dissolves it slowly, and it works great. But if you're going to use pellets, you got to chop them all up, put them in a bucket, and mix them around, then dump it down. So the placement of the chlorine, you're just going to dump it in the top. The concentration is very important. Once again, the pH of the water is more important than anything. We can develop it with surging or airlifting if you have a big problem with bacteria. But quite often, we just take the hose, just run it in the top of the well. Throw your I like the granular myself. You just run that down and let the hose run back into the well for 2 hours, and then let it sit overnight. The next day, you put the hose out, let it run, and get the chlorine out of it, and then take your test. And you can see where the top of that T is filled with iron bacteria, and the iron bacteria just gels in there and then plugs off pipes. So that well would be a candidate. The cracks in the rock do the same thing. That iron bacteria plugs them off. Yeah, and to see if a well has a lot of iron and slime in it, that's the back of a toilet. You run your hand around the back of that toilet. It's all slimy feeling. You got slime bacteria, and you got slime is polysaccharide slime, and iron bacteria is slimy. A couple of drill rigs. The cable tool rigs on the left, rotaries on the right. Wellhead protection. Ensure the quality of the water. Protects well casing against the mowers and other equipment. And like I said, that well cap that was broken before was probably hit with a lawnmower. Do not pile snow or leaves on top of the casing. The leaves have mold and mildew inside them. And so when the pump comes on, the water level goes down in a well. It sucks that mold and mildew in with it. Do not place the decorations over the top of a well, because those decorations, once again, mold and mildew will grow inside them. Make sure casing is at least a foot above ground and there is good drainage around the well. Avoid mixing or using chemicals within 100 feet of the well. And if it's a very shallow well, tell them don't tie their dog to the well casing, because the well's got to be 75 feet from a septic system. And what's a dog? A walking septic system. This is a typical pitless adapter. It's through a plastic casing. And this is the most sanitary thing you can do for your well. Extend the well casings up, put them in. It's another shot of it. And that's how it comes apart. It's just a slide joint. That's all it is. And that's the way you drill an 1 3/4 hole through the casing. That rubber grommet goes on with a washer, and a big nut goes on there and seals the well so no surface water can get in. On the new caps today, you have to have these what they call vermin-proof caps, so the bugs can't get in. That is the 10 micron screen, but it vents the well, and it takes a pretty small bug to get through that. Click. And that's what the well caps look like. It's the ring with the black big rubber disc on it. When the cap goes on, you tighten the bolts, and it squeezes that disc out. And your electric wire goes to the 1-inch hole. That's where you squeeze that. That's the rubber gasket can squeeze down.
Henry, on the previous picture, there's a little screw coming up in there, and I never could figure out what that was for. If you go back one more, yeah, you'll see right to the top left, there's a little bolt that sticks. Yeah, exactly. No, on the upper one.
Oh, that's the vent.
Right there?
Oh,
No, that's a bolt.
sometimes
Out of there.
all wells are supposed to be grounded, and they put that ground nut on there. And if you got a ground coming from inside and one coming from up the well, it's okay. But really, you should be grounding the well pump to the casing, because this rubber gasket in there, you're not really going to the casing. So there should be a hole through it. It's just a salt pile contaminating all the area around it. Well, summary: elimination of well pits is what you really want to always recommend to people. Extend all well casing 12 inches above ground. Annual disinfection of a well once a year at least. Go on a program with these people. I'll come back and disinfect your well once a year. Give you a service call, a couple $100. Disinfection of well, anytime work is done on the well. We always, when you do a pump job, we always throw chlorine in the well. Always do water quality testing, and always have a licensed driller or somebody who knows what they're doing the pump, not the guy next door. Recommendation to homeowners: set up a schedule for routine annual maintenance, well inspections, flow testing. Yeah, this is getting a little wild, but flow testing and the water, check the water levels, pump and motor performance. You really can't check that. It's good, either they work or they don't. And the water testing, general water quality, and laboratory and health department testing. That's all you get.
Okay.
Hey, Henry,
Thank you so
much. I had somebody asked one question. I don't want to leave anybody out.
Sure.
And I know we're past. It says your feelings on dug wells and basements.
Dug wells in basements. Let's see. There was only one call came in today about a guy with a dug well that went dry. And no, they're not really good ideas. They're not sanitary. There's no way you can stop the mice and creatures and bugs from crawling into them. And you'd be really surprised if you looked in the bottom of them to see what bones are in the bottom of them, between dead skunks, raccoons, and things that get into them and can't get out. So not really good ideas. Always recommend that they drill a real well. It's just, back in the 1800s, that was their only water source. People have had probably more immunities to these things, but today people don't have any immunities to anything. And that's why we have all chlorinated water and everything, so nobody ever gets any immunities. So that's why we're such a sickly outfit now. But not that I'm recommending you drink out of a brook to get immunities. There's too many things in the brooks today. But yeah, you want to have a sterile area to drink your water out of.
Henry, there's a section in the northwest part of Connecticut, around the lake especially, and I guess because of the swampy nature of it and/or high water tables, and they can't get equipment in there or won't get equipment in there to drill wells. Everything I saw it that way was a machine dug well, modern, from the 80s, 90s, or even more recent. But the machine dug, you open up the lid and you're looking down a 3-4 foot diameter, well sleeve, and you're going down, I don't know, maybe 12, 15 feet, and just nothing good was coming from that, in my opinion. But yet somehow the town is allowing that.
There's certain areas. Well, if you go any deeper, you get into really irony, crappy water, and so there's certain areas where there's one of the lakes up there. What town's it in? It's around the lake. We put in points up there. A point well isn't the greatest well, but it's like a hand dug well, but it's just a screen on the end of a 2-inch pipe we drive in the ground, or 1.25-inch pipe. And we drill a hole and then we drop the point in and sandpack it, and we put bentonite around it to seal it. But
so a driven point well is better than a machine dug well. That's what you go to.
Yes, definitely. If you have the formation that warrant it. Some people just have a very, very slow flow of water in the ground. And so the hand dug wells, if you have clay and you dig a hand dug well, it's so big around, it holds a lot of water and it can fill up very slowly. For a point, you have to have good sand to get a good flow out of it.
Thank you.
Well, Henry, thank you so much for tonight. We went a little over. We really appreciate your time and your information. We'll put your contact information on our website, so maybe we can get you some referral business.
Yeah, anything would be great if you can. But I'd much rather do it in front of you than bring all my little toys with me and give me a little more time.
Well, I'm going to take you up on that when we do some in-person stuff, Henry. I promise.
All right. We'll try to be here for you. Thank you, guys.
Okay, thank you, Henry.
Sure.
Thank you.